if 6.1.1, we have goodness of fit test, which we want to compare the observed value and the expected frequency that we expect from the sample. And 6.1.2, we will have fitting of the distribution. We want to know our distribution, our data or our population fit in which distribution. Is it Poisson, binomial or normal? So Poisson and binomial is for discrete and normal is for continuous variable. Okay, so in this section, we wish to fit a set of data from an unknown population to a particular distribution, namely binomial, Poisson and normal, using goodness of fit test. Okay, so when we want to test our population in fit in which distribution, we talk about the test, we also have the procedure. So procedure of goodness of fit test for fitting of the distribution. Step number 1, still the same, your H null and H1. Okay, step number 2, same. In goodness of fit test, we will use chi-square test. This is the formula for the chi-square test. Step number 3 is the critical value. So you notice here, the critical value we have chi-square alpha, the significant level, and then K minus M. K is the number of category, M is the parameter, minus 1. So notice here, take note, M. If the parameter value is given, your M is equals to 0. If the parameter value is not given, your M is equals to 1. Okay. So, this is a right tail test. And then, step number 4, you make a decision to reject or to accept the H null. And then draw the conclusion. Okay, what is the hypothesis? H null, the population, come from a specific distribution, or the population follows specific distribution. And then H1, if H null follows, H1 does not follows. The population does not come from specific distribution, or the population does not follows certain distribution. Okay, for example, H null follows Poisson distribution. So H1 does not follow Poisson distribution. H null follow, H1 does not follow. H1 come from H null come from, H1 does not come from. Okay, and then the test statistic, and then the E and I, and then the conclusion, decision and the conclusion. So let's look at example 6.2, Poisson distribution. The number of defects in the printed circuit board is hypothesized to follow a Poisson distribution. Poisson distribution. A random sample of 60 printed board has been collected and the following numbers of defect is observed. Okay, this one is the frequency, this is number of defect. So tak ada defect langsung is 32. 1 defect is 15. 2 defect is 9. 3 defect is 4. Test the hypothesis that the number of defect in the printed circuit board follow a Poisson distribution at 5% significant level. So you have to test the number of defect in the printed circuit follow Poisson or not. Okay, so what is your hypothesis? H null, H1. Right? So H null, the number of defect follows Poisson distribution. H1, the number of defect does not follow Poisson distribution. So that is your H null and H1, step number 1. Step number 2, you want to find the chi-square test. In order for you to find the chi-square test, you need the E. In order for you to find the E, you need the P, because E is equals to NPI. So P, how to find P for a Poisson distribution? So don't worry, P will be given. For fitting of the distribution, P will be given. Right? So in this example, P1 is 0.4724, P2 0.3543, P3 0.1329, and P4 is 0.0404. Okay, you don't have to worry about the P. P will be given. So P is given to you. And then from this P, you have to calculate the E. How to calculate the E? E is equals to NPI. Alright? So E NPI. Our N is equals to, what is our sample just now? 60. So N equals to 60. So N equals to 60 times the P. P is 0.4724. You will get the E. Okay, and here we get the E. So notice here, E is less than 5. The assumption for goodness of fit test, E must be greater than or equals to 5. If your E is less than 5, what you have to do? You have to combine it with these adjacent categories. So 2.424, you have to combine with 7.974. Okay, when you combine the E here, you also have to combine the O. So from here, you have 1, 2, 3, 4. 4 categories, K equals to 4. So when you combine it, your K will become 3. It will look like this. Okay, 1, 2, 3. So K is equals to 3 now. So now, why 13 here? Because we plus 9 plus 4. We combine it, we get 13. Why 10.398 here? Because we combine here 2 plus here. You will get the 10.398. Now you have the O, you have the E. What you have to do? Substitute into this formula. You will get the chi-square test 2.965. Okay, step number 3, the critical value, chi-square alpha K minus M minus 1. Alpha is 0.05. Our K now 3. After we have combined it, so K equals to 3 minus M. M is the hypothesized mean. M is the, this one. M represents number of parameters of the hypothesized distribution by sample statistic. Okay, if the parameter is given, your M equals to 0. If you have calculated the parameter, M is equals to 1. Okay, so now for this example, the parameter is lambda. You have to calculate. So because you have to calculate, M is equals to 1. Okay, so now M is equals to 1 minus 1. So chi-square alpha 0.05. 3 minus 1 minus 1. 3 minus 1 is 2 minus 1 is 1 is 1. Okay, you will get 3.8415. So this is a right tail. So here 3.8415. Your chi-square test is 2.965. 2.965, 3.8. Greater than or less than? Less than. So 2.965 is here. Okay. Since chi-square test is less than chi-square critical value, we accept H null. So what will happen? You accept H null. Look at back here. You accept this one. Okay, means that at alpha 0.05, the number of defect in printed circuit follows a Poisson distribution. Okay. So look at another example for the binomial distribution. A farmer kept a record of the number of heifer calves born to each of his cows during the first 5 years. The results are summarized below. Test at 5% significant level whether this data adequate for binomial distribution or not with parameter n equals to 5, p equals to 0.5. So look at here, parameter is given. So when you want to find chi-square alpha k minus m minus 1, because parameter is given, m is equals to 0. Okay, noted that. This one. Okay, when you want to find the critical value, m equals to 0 because parameter is given here. Okay, how to solve the example 6.3 about the number of heifer. Okay, step number 1, the hypothesis. H null, number of heifer cow, follows binomial distribution. And the alternative will be number of Havercorp does not follow binomial distribution. Okay, step number 2, you want to find the chi-square test. In order for you to find the chi-square test, you need the E. In order for you to get the E, you need the P. Okay, so don't worry, P will be given. So P will be given here. Okay, now you have to calculate the E. How to calculate E? E is equals to NPI. So N, how many N? How many sample size? How many total frequencies? Go back to the equation. So, when you sum up this one, okay, you will get N is equals to 150. Right? So, the total frequency is 150. So, N is equals to 150. So, N times P. P is 0.0313. You will get 4.695. Next, N times P. P is 0.1563. You will get 23.445. Okay. Next, E3. E for 150 times 0.3125. You will get 46.875. Okay. Next, 150 times 0.1563. You will get 23.445. And then here 150 times 0.0311. So take your calculator. 0.0311 times 150. You will get 4.6650. Okay. So now look at your E. Is it all your E greater than 5 or equals to 5? No, right? Your E here is less than 5. E here is also less than 5. So what you have to do? Combine it with the adjacent categories. So E1 combine with E2. E5 combine with E6. Tambah. Sum up. So plus. When you sum up the E, don't forget to sum the O. So, how many categories we have just now? 1, 2, 3, 4, 5, 6. K is equals to 6. When we combine, now, this one combine, it will become 1, 2, 3, 4. So, your table will look like this. Okay? This one is observed. This one is the E. E, this one, we sum it up. Also, this one, we sum it up. We will get the E here is 28.1250. This one is also 28.1025. Okay, so when we combine this one, you will get 23. Here is 34. 1, 2, 3, 4. K is equals to 4 now. From K is equals to 6, it will become K equals to 4. Why? Because we combine the E, we also have to combine the O. So now we look at here, our E all have greater than 5. So after you get the O, you get the E. Now you want to find the chi-square test. So how to find the chi-square test? O 23 minus E 28.1250 square root divided by E 28.1250 plus 41 minus 46.875 square divided by plus 52 minus Okay, you sum it up, you will get the chi-square test is equals to 3.4682. So this is your chi-square test. Right, so now chi-square alpha k minus m 1. Okay, chi-square alpha is 0.05. K, now k is equals to 4. 4 minus m. m. Is it parameter is given? Yes. So m is equals to 0 minus 1. So chi-square 0.05. 4 minus 0 minus 1 is 3. So look at your stat table. Chi-square alpha 0.05. Nu is 3. You will get 7.841. 7.8147. Okay. Right. So now compare. Our chi-square test is 3.4682. Our chi-square critical value is 7.8147. Is it chi-square test is less than or greater than critical value? 3.4 is less than 7. So since chi-square test 3.4682 is less than chi-square, what you have to do? Do not reject H null. You accept H null. So what will happen if you accept H null? So you accept this one. At alpha 0.05, number of Hefferkau follow binomial distribution. Okay, done for the fitting of the distribution for binomial distribution. Okay, now example 6.4 is about the normal distribution. So example 6.2 is for Poisson. Example 6.3 binomial. Now example 6.4 normal distribution. The sugar concentration in apple juice measured at 20 degrees C were reported in article Food Testing and Analysis for 50 readings in the frequency distribution table. The sugar concentration in apple juice measured at 20 degrees C were reported in article of Food Testing and Analysis for 50 readings in the frequency distribution table below. So 50 reading, so total frequency and equals to 50. Okay, you have the concentration can be categorized by 1 until 1.2, 1.3 until 1.5. They class the concentration into classes, and then the total frequency is 10, 15, 15, 10. Right, the first class 10, second class 15, third class 15, fourth class is 10. At 0.025 level of significance, so alpha 0.025, is there any evidence to support the assumption that the sugar concentration is normally distributed when mu equals to 1.5 and sigma 0.5? So now the parameter is given. So m is equals to 0 when you want to find the chi-square critical value. So now they ask you to test that the sugar concentration is follow normal or distribution or not. So you will have the H null and H1. H null, concentration of sugar follows normal distribution. Concentration of sugar does not follows normal distribution. Okay, that one is for the hypothesis. So, step number 2, you want to find the chi-square test. Okay, in order for you to find the chi-square test, you need the E. So, for you to get the E, you need the P. Right? So, don't worry, P will be given. Why we give P to you? Because it's very tedious for you. You have to recall back your normal probability knowledge to get the P. Okay, so now for this course, we will give the P to you. How do we get the P for normal distribution? So this is the ways how we want to find P for normal distribution. So now we will give you the P. P is 0.1728 and then 0.2313, 0.2182, 0.1452. Okay, now what you have to do is you have to find the E only. Alright, so O is your actual data, E you have to find. So the expected frequency, just now P for this one is 0.1728, 0.2313. So here is N equals to 50 times 0.2313. Here 50 times 0.2182. So here 50 times 0.1452. Okay, press your calculator, you will get the E. So E here is 11.565, 10.91, 7.26. So you get the E now. So can you calculate the chi-square test? Yes, you can calculate the chi-square test. 10 minus 8.04 square divided by 8.04 plus. So what is your answer here for the chi-square test? Chi-square test, my answer is 3.8. Okay, so step 3 here, chi-square alpha 0.025, K 1, 2, 3, 4. 4 minus m equals to 0 minus 1. So you will get chi-square 0.0253. Look at your stat table, you will get 9.3484. Okay, so decision. Since chi-square test 3.8 is less than chi-square critical value, accept H null or do not reject H null. So at alpha 0.025, concentration sugar follows normal distribution. Okay, done for the example. You have the exercise. So please try to do this exercise 6.1.2. The receptionist in hotel monitored the telephone calls for 24 hours and the number of calls per hour recorded in the following table. Test the claim that the number of calls per hour follow a Poisson distribution with mean of 1 call per hour. So lambda here equals to 1. So parameter is given. Parameter is given. So what you have to do? So in order for you to find the chi-square, your m will become 0. Okay, can you do it on yourself? Step number 1, the H null and H1. Step number 2, the chi-square test. Okay, the PI. So PI will be given. So you can look at the file in the Google Classroom, the PI for 6.1.2. Okay. So 6.1.2 number 2 is about the binomial distribution. They give you the parameter, right? And you have to test, is it fit the binomial distribution or not? So the value for P is also given in your Google Classroom. So please try to do number 2 and also number 3. Okay, about the normal distribution. the p-values is also can find the file in the Google Classroom. So please try to do number 1, number 2 and number 3. Okay, you can submit through Google Classroom. Thank you.